Hello everyone and welcome! In today's video I'm going to be explaining intercoolers. Now this particular intercooler is a bar and plate style air-to-air intercooler courtesy of Yonaka Motorsports, so I will include a link in the description if you want to check out the actual product, and I'll get more into what that means, air-to-air and bar and plate design in this video. So first I want to talk about, well, what is the purpose of an intercooler? So the purpose of an intercooler is to reduce the intake air charge temperature. So if you're going to have a turbocharged or supercharged engine and you're going to have, say, 15 psi of boost going into that engine, you would rather have 15 psi of cold air than 15 psi of hot air, because that cooler air is going to carry more oxygen and allow you to burn more fuel and thus create more power. And it's also going to be less likely to combust before you'd like it to, since the temperature is initially lower. So let's start to talk about kind of what an air-to-air intercooler is, what it means that this is a bar and plate style intercooler. So an air-to-air intercooler means that you're using your ambient air in order to cool the air of the intake charge. So what we've got going on here is, here's our engine, here's our turbocharger, it could be a supercharger also, and here's our intercooler, and this is our system setup. So we've got our cool air coming into the intake of the turbocharger. Now, as air compresses, as you squeeze that air down, it heats it up. You're also going to have a little bit of heat from the exhaust side of the turbocharger heating that inlet air. So once the air comes past and has been compressed, it's going to be heated up, so you're going to have hot compressed air that you're going to be sending to the engine. So you don't want hot compressed air, so that's where this intercooler comes in. So you have air pass through the front of the intercooler and out the back of the intercooler, and inside you've got your intake charges going from hot, you can see here in red, to cool air. The other type of intercooling system you may find is an air-to-water intercooling system. Once again, it can be done with a turbocharged or supercharged application. For this I've drawn a turbocharger. So an air-to-water intercooler is using water to cool the intake air charge. So it works a little bit differently. So same idea where we have the intake of the turbocharger, you compress that air, it heats it up, and then you want to send that air to the engine. So instead of sending it directly to the engine, it first passes through this intercooler. And in this intercooler, you have a channel of water flowing. So at the front of your car, you have this radiator, and this radiator, the ambient air is passing through it and heating up, and as it passes through it, you have this pump pumping fluid. So the hot fluid is going to come in on one side, and then as that ambient air cools it, you'll have cool liquid coming out the other side. So that cool liquid will go to a second radiator system basically, and so you will pass the intake air over top of these cooling fins connected to this cooling circuit here, and so that's going to cool down the air that's coming in for the intake charge. So you'll have the hot air compressed coming in, and then you'll have cool compressed air coming out and going to your engine. So this air-to-water intercooler is going to look a little bit different, because basically you're going to have your intake charge going through this side of the intercooler, and you're going to have a coolant running through this side of the intercooler. And one of the things that you can do with an air-to-water intercooler is you could take out this front-mounted radiator, and instead you could just kind of put an ice chest or reservoir in there, and so you could be pumping ice water through the intercooler. And that'd be good for applications where you're not running the car very long. For example, like a drag racing, or perhaps like a hot lap, a single lap task where you're not using the car for very long and you just need to cool it as much as possible. And by doing that, by using a water chest filled with ice and having colder water, then you can actually get the compressed air to be cooler than the outside air temperature. So let's talk about the pros and cons of air-to-air versus air-to-water. So an air-to-air intercooler, typically the system is going to be a lower weight, it's less complex, and it's going to be cheaper than implementing an air-to-water intercooling system. However, on the flip side, air-to-water systems typically can be more effective, and they also have a decreased pressure loss, since the intake is actually much closer to the engine, and you're not running it through this complex route of through the intake, down through the front of the car, and then back all the way to the engine. You can kind of place the intake much closer to the engine and have a shorter distance, so that your pressure loss through the system is less. So I also mentioned that this is a bar and plate style intercooler, and so basically that just has to do with the construction here. So it has these plates stacked on top of each other, and that's just how it's constructed versus a tube and fin. So looking internally, the air flowing in through this direction, it's going to kind of look like this for a bar and plate, where you have these different sections where the intake charge can pass through, versus these extruded tubes, which a tube and fin style intercooler would use for the intake charge to go through. So here's just a quick look inside of the bar and plate style intercooler, and this is what the intake charge would be passing through. So now the pros and cons of bar and plate versus a tube and fin style. Typically the bar and plate is going to have, it's going to be a stronger intercooler, can handle a little bit more abuse, higher pressure boost levels, and it also is typically going to have greater cooling. That said, the tube and fin, it's typically going to weigh less, it's typically going to cost quite a bit less due to the manufacturing process, and it's going to have less of a pressure drop. Now that less of a pressure drop means you're going to have more air to flow to, for example, if you have a radiator behind it, you're going to have more air flowing to that. But note, it's not going to have the cooling that a bar and plate might have. So finally, I just would want to talk a little bit about the design of intercoolers overall. So one thing to take into consideration is the fin density, both passing through the intake charge path and passing through the outside, the ambient air path. So the fin density, as you increase that, you're going to have more cooling, obviously. But as you have more cooling, you're going to be slowing down the air more, and you're going to have a greater pressure drop from one side of the intercooler to the other. So you're not going to have quite as great airflow through it, and also the pressure from here to here is going to decrease a decent amount. So if you have it really restricted, you may be able to provide high boost levels with your turbocharger, but if it's too restrictive, you won't have that high boost after the intercooler. So that's one thing to keep in mind. Also, another thing to keep in mind, changing the height of the intercooler. This is great because you're going to increase the cooling of it, and typically most of the cooling is done right here. So as the length of this increases, it's not going to be that much more effective because the difference in the temperature between the ambient air and the compressed air isn't that great. So when the temperature difference is small, you're not going to cool it much more, versus when the temperature difference is very high, you will cool a lot more. So having a high intercooler allows you to maximize that point where the air is very hot and the outside air is very cool, and you can clash those two temperatures together and get better overall cooling from the intercooler. That said, you can't just make this really tall intercooler because the size of it's enormous and it's just not going to fit in vehicle applications. And then finally, the thickness of it. So like I was saying, size can be a problem, so you can make the intercooler thicker, have the air pass through it more, and although that allows you to use a smaller size, it's going to decrease your airflow through the intercooler, so you're going to have a greater pressure loss, and you're not going to have quite as great of cooling for your radiator, which typically is going to be behind the intercooler. So thanks for watching. Feel free to check out the links in the video description, and if you have any questions or comments, feel free to leave them below.